Okay, so welcome to the Hadoop Summit and the Hadoop Crash Course. So we're going to go through a lot of material in the next 2.5 hours or so. My name's Rafael Cos. I am a data evangelist at Hortonworks. And this is our agenda for today. So I want to talk a little bit about the future of data, what's our challenges with data, and as a backdrop to try to understand, why Hadoop? Why did Hadoop and its ecosystem sort of evolve? Then we'll talk some about traditional data architectures. So like, what's the challenge, what's the challenges with the traditional data engines, and what are some of these challenges that then Hadoop tried to address? Then we'll get actually into some of the meat is what is Hadoop, in particular, what is Apache Hadoop? We'll talk some about a Hadoop distribution. And then we'll get into talking to you about the various data access engines. So as you look at Hadoop and you store data in Hadoop, unlike other data processing engines, there's actually multiple ways to interact with that data. And lastly, and probably most importantly, we'll get into the lab. Right? So the idea is try to give you a quick introduction, get some context about what Hadoop is, hopefully answer a couple of questions along the way. If there starts being a lot of questions, we have plenty of time to answer questions during the actual lab time. So maybe I might ask you to kind of wait off for a particular question into the lab time. And then really I want folks to be able to get hands-on to kind of learn, and then there'll be a couple people helping. We'll go around and go through that. So to talk about Hadoop, part of this is let's look a little bit about how people have been using Hadoop. So as we look at people's journey to Hadoop, there's really 6 ways that we've been seeing customers adopt Hadoop, right? And those really come into 2 flavors. One is the innovate, and the other is the renovate, right? And I kind of see this as you can look at the glass is either half full or half empty, right? So it's half empty. You can potentially, this big data phenomena is a challenge to you, right? So that's really the renovate. How can I sort of better optimize my existing infrastructure and use Hadoop to do that? And if you see the glass as half full, maybe you're looking at Hadoop as this opportunity. This is opportunity to change your business processing, to be able to leverage the data in a new way to kind of change the way you drive your business. So as we look at the renovate track, probably the one that kind of sticks out the most is this thing around active archive, right? And active archive is really talking about, hey, I have lots of data that's potentially in my data warehouse. I might be paying a lot for that data. How can I offload some of that to a different platform in order to optimize my cost for that environment? And in a similar sort of fashion, you can kind of be looking at sort of ETL. So maybe you're using your existing data warehouse to do transformation of data. And one way to optimize that environment is potentially onboard that ETL onto sort of a different platform, use a more cost-effective platform to do the transformation and data processing, and then once you refine that data, then maybe put it back into your data warehouse, right? And that's really where we see this data enrich, right? So when we look at the data enrich, the data enrich is really about I've done some processing in Hadoop, I've enriched the data, now I want to kind of potentially put it back into my warehouse, right? Sort of in a similar fashion, as we look at the innovate track, what people are trying to do around Hadoop, around the innovate track is, first and foremost, sort of looking at something like data discovery. And so when they look at data discovery is, okay, so one way to kind of look at this is, relational database, it deals with tables, so we'll call that the square. And if you have something else that doesn't fit into that square, then you start trying to shave off your data to kind of make it a square to fit into that relational table. So if you have other data formats that you want to explore and want to have a more flexible manner to do that, Hadoop could be a great way to do that. So whether it's JSON data, log data, image data, video data, other data that tradition doesn't fit into your relational environment, and you wanted to start doing exploration around it, it's a great way to kind of leverage Hadoop. The other one is around single view, right? And the single view is okay, maybe I have my customer information, my product information, all in my relational world, but I'm also can potentially leverage additional data sources, maybe from my social channels, Twitter or Facebook, or I have other CRM call records that I want to leverage to get a bigger perspective of that customer or that product, to get a bigger version of that. So I'm going to build a single view that takes my relational data and takes additional data, and so I can get a better understanding of that environment. And lastly, it's something around predictive analytics, right? And so predictive analytics, I know a couple of people kind of were coming in and were asking me about some of the other crash courses. We have some around Spark and data science. It's really looking at this, okay, I've refined this data, I've absorbed more data than I have before. Now I want to be able to, and I've been able to analyze it to see what happened in the past, maybe why something happened. And now I want to potentially ask the next question is, when will this happen again, right? And can I do prediction with this data? And in particular, maybe you've done some prediction models before, but can I leverage more data and a variety of data than I have before to try to make better predictions, right? And these are really the sort of the 6 classic ways that we're seeing customers look at Hadoop. So with that, let me see. So let's talk a little bit about the future of data. So as we look at the future of data, and we're starting to talk about the future of data versus sort of big data, because I think we're really trying to enter like a next phase of this data processing, right? And as we look at data, we keep looking at modernizing our data architectures. And I think as we kind of look forward, one of the key things is this whole notion around actionable intelligence, right? And so actionable intelligence is about deriving from a constantly connected society with security to enrich data sets from the Internet of Anything, right? So as we look at the Internet of Anything versus the Internet of Things, so Internet of Things, we're particularly sometimes looking at mostly metal that moves, right? Or devices. So so there's some folks back in the back right corner, working with some devices and the Internet of Things sort of situation. But at the Internet of Anything, you're potentially not just looking at sort of metal that moves or just pure sensors, but other telemetric data, potentially from logs or your mobile devices. So it's not just sensors, but additional sort of data sources. And as we look at those, we want to have sort of actionable intelligence. And the actionable intelligence is not, we don't want to take an action, in a week. We want to be able to take an action now. So be able to have that better understanding, use that better understanding right now to make better decisions for your customers and your products and the environment you're dealing with. So one way kind of looked at it is around sort of driver safety. And as we look at this, here's some metal that moves in a car. And cars are really starting to become this next connected sort of platform. And yes, there's sensors in the car to talk to you about the speed, the direction, how are your brakes, where's your oil pressure. But there's also location. You're potentially dumping some of this. You're also kind of you interact with your car when you're driving, but maybe you're also interacting with your car from a mobile device. When you're kind of going to get service from that car, right? So you want to be able to not just get the data, real time from the car as it's moving, but take a bigger picture of your experience with that car, whether you're driving, not driving, putting it into service, right? Looking at it from a website perspective, right? So as we look at this phenomena, so we have sort of your traditional growth of data. So as you look at your traditional growth of data, data has one intrinsic property, is that it grows. You build any database system, it's a relational system, and it's just going to grow. But what happens with data in Hadoop and big data, what you're seeing is an inflection point. At the rate at which data is kind of growing has changed. So in particular, as you look at some of these new data sources on your left, whether it's clickstream, weblogs, geolocation, that data is growing. So as that data grows, then you have this challenge. You have your ability to consume that data. And maybe that ability to consume that data is not keeping up with the growth of the data itself. So what that lends to you is this thing called the enterprise blind spot. So what the enterprise blind spot's about is you might have the data in your enterprise, you have it available to you, but you're not able to take advantage of it. If you're not able to take advantage of it, maybe you're not making the best business decisions that you can, even if you have the data. So it's leaving you a blind spot. You have an opportunity to change your business direction, but because you're not able to consume and leverage that data, you can't take advantage of that. So we're here at the Hadoop crash course at the Hadoop Summit, and the 10-year sort of anniversary of Apache Hadoop. And so some people can look at this as Hadoop as being this disruptive technology, but is it really, right? And what I would sort of propose is that it's not so much Hadoop that's being disruptive, it's data that's being disruptive, right? And the amount of data that we have the opportunity to consume has changed. So let's take a closer look at what's happening with data. So one, clearly social is generating much more data than it was before. Our mobile devices are generating more data. So we're interacting much more with either the internet or the device itself, right? I mean, there's so many sensors within your mobile device that's generating more data. Cloud, right? So the fact that you have this flexibility to more quickly stand up applications and potentially stand up situational applications, that's also potentially generating more data. And last but not least is the Internet of Things. So as more and more sensors go into different devices, that's also generating more data. So as we look at modern data applications, I want to cover a couple of concepts. One is, we talked about this concept around data variety, right? So there's all these different data types, and we want to have a more flexible way to be able to consume, analyze, and process that data. And so some of this is that you have your traditional SQL, then there was the whole NoSQL, and then NewSQL. So the whole NewSQL idea is that I want to have the flexibility of a NoSQL architecture, but I still want to be able to do SQL there, right? And so you have graph processing, you have search, so you have this various data stores where you're processing data. And you're doing that both at rest, right? And so when we talk about rest is, hey, you have a relational database, the data, you insert the data into a table, it's sitting on a disk, that's at rest, right? And then there's also this whole notion around data in motion. So when you deal with Twitter and you're at your Twitter feed and you can see this continuous stream of data, that's data in motion. Or as you're looking at a device, whether it's yourself moving with your phone or you're moving within your car, you have this continuous temporal stream of data, right? So you move, you have a new geolocation. You move, you have a new geolocation. You move, you have a new velocity that you're dealing with. And there's a growing amount of new data sources, in particular in the IoT, that's this continuous stream of data. We call that sort of in motion. So one of the things that's happening with these, as we have these variety of data, previously, as a data engineer, a data architect, you had one primary tool, which was your relational database. And so any data problem came your way, what did you do? You grabbed your one primary tool, you got your big hammer, right? It says, hey, the way I'm going to solve that, I'm going to stick it into my relational database. And now what we've come to a point where we live in this polyglot persistence kind of world, where yes, we still have relational databases around, but we have a lot more options. Right, where data gets stored from a source perspective and where data might be processed from an analytics perspective. And that's sort of this whole notion around polyglot persistence. Then we have, as we have these additional data sources and we live in this polyglot persistence kind of world, we want to do analytics on that. And so now we need to be able to deal with all these different varieties of data and data stores and at rest and in motion. And anytime you want to try to do kind of analytics, the first and foremost thing that you want to do is have a way to integrate that, right? So when you look at your traditional data warehouse, you might have multiple relational operational stores that you then suck data into the data warehouse, and you're moving that data into the data warehouse and building some kind of data lake, right? In the case of Hadoop, you're kind of looking at a much larger data lake. So that's one way to kind of integrate data, move it into one common repository. The other sort of way to kind of try to integrate data is this whole notion around federation. Let the data live out there, wherever it is, and have some really smart way to kind of pull the data together. And when I say smart, try to reduce the amount of data you need to put together to kind of answer your particular question, right? And as we look at these sort of modern data architectures, you'll have the ability to, with Hadoop particularly, build a larger data lake, and sometimes with Spark, be able to sort of have a smart way to access remote data sources, bring that data into memory, and sort of process it. And the idea is not that, okay, it's sort of this battle between one or the other. It's really about an architectural decision, right? And as you become as we keep evolving as data artisans, where before you had one tool, now you have a whole collection of tools. And now it's about trying to use the right tool for the right problem. So, and as we do that, it's becoming much more sort of this optimization, right? So we're sort of looking at optimizing storage. We're looking at optimizing compute. And also sort of along those same ways, we're looking at, in some ways optimizing the hardware, right? So as we look at many of these tools, in particular Apache Hadoop, we're looking at a distributed computing environment, right? Where we have this collection of machines called the cluster that kind of work together as some kind of supercomputer, right? And one of the sort of benefits about Hadoop is we get to leverage this commodity hardware. So we're trying to leverage distributed computing at sort of a lower price point. And as we look at sort of these price points, cloud clearly becomes another thing to sort of consider as you're looking at optimizing. So here it's like, we're really sort of approaching this hybrid distributed computing sort of environment. And all these trends are sort of shaping Hadoop and sort of where Hadoop is going sort of into the future as we look at building modern data applications. So as we look at these building these modern data applications and trying to build sort of actionable intelligence, we're going to have sort of this area to the right where we sort of looking at data at rest, right? And in that data at rest, we have this larger data lake which has ability to store a wide variety of data coming at a high velocity and being able to sort of do it at a lower cost point. But at the same time, we have this continuous stream of data that we're also ingesting. So if you're going to build a data lake, you're going to need a stream, right? So somehow data needs to come in, right? And so that this is where this data in motion comes in. And as we look at this data in motion and data at rest, somewhere in between, when we can integrate these two systems, we have this new sort of opportunity to do actionable intelligence. So as you have a better understanding, that single view of the customer, that historical perspective, taking into considering more dimensions that you were able to do before, now as data is kind of streaming in real time, now you have an opportunity to react to that data in real time with this new insight. And that's what we sort of refer to as actionable intelligence. So let's kind of take a closer look at traditional data architectures. So as we look at data systems, traditionally we have this idea of a system of record, right? And the system of record is just your repository, you store your online transactions. And you have some system of insight where you integrated traditionally relational OLTP systems into some kind of warehouse. And then we have this sort of notion of systems of engagement, where we're sort of trying to have this social interaction. And as we keep evolving, we're looking at there's these systems interaction. So the systems interaction is I want to take a personalized insight into a particular customer, a particular behavior, and not a generalized. So it's, yes, you're having that social computing interaction, but as you have that social computing interaction, have a personal experience. So if you're having a drop call, hey, the call carrier knows, hey, you just had a drop call. And when you call in, they know that already, and it kind of reduces sort of the troubleshooting perspective. And that's where people want us to design these systems of interactions, right? And then you want to have, when you look at the analytics, you're also looking at systems of intelligence, and that's where you're starting to leverage more of this machine learning kind of capability. So we have these systems of record, right? Where whether it's sales or CRM or ERP, and when we want to do analytics, what typically need to do is we need to kind of bring the data together, right? So oftentimes it's come together into a data warehouse, but in order to kind of bring that data together from the different repositories, we might need to do some transformation along the way. So the common paradigm here is I start with my systems of record, I build some kind of EDW sort of integration sort of platform to bring that data together. And then at some point when I want to do the analytics, I move some amount of data from my EDW to my analytics area, whether that's my OLAP, my statistics environment, my reporting environment, and then I do that processing. As data grows, clearly this starts stressing traditional environments. And as you keep growing the data, the amount of data that you need to bring into your analytics environment is also being stressed, right? Because not only do you need to kind of move the data into your warehouse, you also need to move the data into your analytics. So, physically sometimes, that can just be a challenge. And, one way to kind of like try to optimize this environment is to maybe take some of that data from your warehouse and archive it, right? But one of the challenges is when you archive your data, you're basically almost killing that data, right? Because your ability to use that to do analytics is going to go away, right? Because it's hard to get that data back into an environment where you can actually keep doing queries and analytics on that data. So now you're optimizing your environment to try to control costs by archiving, but you can't leverage it to kind of get a bigger perspective. So not only do you have to kind of deal with traditional relational environments, but you also need to kind of deal with some non-traditional environment. Non-traditional relational data. So if you start dealing with log data, you also need to kind of bring that environment. And as you get into mobile, you're also kind of dealing in that similar environment where you're now dealing with this non-traditional data that you might need to get into the ETL process to integrate it. And same thing with like if you have some application server, now that has additional log data that you're collecting through the web, like clickstream analysis, that you might want to bring, process, and then get to an environment. And as we keep looking at more and more rich data, you can sort of see like, hey, here's a large variety of data that if my bottleneck becomes having to transform it and get into this workflow, one is this is challenging, two is it can be slow, and the other thing it could potentially be expensive, right? So one of the things that we want to do with Hadoop is we want to sort of have an environment where it's easier to kind of bring data in, not having to go through sort of a relational environment and have access to it. So as we look at traditional architectures, they have a couple of challenges. One is as you try to grow that system, it can become pretty expensive, and not just expensive, but slow to be able to consume that data. Getting that data prepared, doing that transformation can be expensive from a cost of that environment. It can be expensive from a time perspective. And when we look at analytics, as we move data from the warehouse to your analytics environment, many times it can be very costly to move to work data in the analytics environment. So you might want to take a sampling. And if you're taking a sampling, you're sort of at some point assuming some amount of risk, right? So if you want to have a bigger perspective, you want to be able to consume more of that data. If your cold data is being sort of archived, that's data that you then therefore can't leverage to kind of do sort of further analytics, right? And this data ingestion, as you're looking at consuming more and more sensor data, it can become challenging to kind of incorporate that data into your architecture. And and this is pretty much mostly just working from a data at rest perspective. And as you're looking at data in motion and be able to react to folks in real time, you need to have the ability to consume that, ingest that, and sort of act on it with sort of intelligence. So here we go. It's like with Hadoop, we have the opportunity to potentially onboard some ETL. Maybe have a more intelligent environment to sort of archive that environment, where we can archive it, but still be able to query it. Do some data discovery. So all these additional data sources that could be potentially challenging, maybe Hadoop can provide a better environment to be able to consume that data and process it. As you consume these data, maybe this streamlines the way to kind of get the data into your data warehouse. And clearly a single view is like, yes, you can incorporate the data from the EDW, but you can potentially incorporate all this additional data into that single view to get a bigger perspective. So as we look at these architectures, there's sort of the traditional and then there's sort of our modern data architectures. And one of the things as we talked about is that traditionally, when you go to analytics, you often only deal with a subset. And when we go into sort of Hadoop and modern data architectures, we want to be able to deal with the whole data set, right? And have a platform that allows us to deal with that whole data set. In a similar fashion, it's like when we want to do the cleansing, oftentimes we need to go through a lot of processing before we can actually look at the data. Part of the thing in Hadoop, we want to have this flexible way to be able to just ingest the data and be able to start exploring that data. So as we look at sort of the way you approach it, traditionally you start with some hypothesis, you have some question, right? You take that question to kind of design, what data you want to capture, right? And then you start answering the question. One of the things that these modern data architectures allow you to do is, instead of kind of starting with a question, maybe start with the data and start exploring the data to see what patterns you can discover from that, right? And oftentimes you kind of use some statistical methods, to try to discover the patterns from the data as you look at larger and larger volumes. And then kind of that trying to lead to sort of actionable intelligence. And you're kind of doing this for both data at rest and data in motion. Okay, so what is Apache Hadoop? Okay, so as we look at these challenges, one way to deal with these challenges is to be able to, as you store more and more data, is, hey, how about we just get a bigger machine, right? If we get a bigger machine, now we can store more data. But these many times these machines are fairly expensive, so you want to have a more cost-effective way to grow that environment. So the other approach is, hey, I want to get a cluster machines, and the cluster machines I want to get are commodity hardware. So you're coming at a sort of a lower price point. And these commodity machines have their individual CPU, individual disk, individual RAM, and I'm going to build a series of abstractions on top of these machines to be able to leverage them as one sort of computing framework. So one of the first things that Hadoop tries to do, as you look at this distributed computing framework, is build an abstraction so that you can abstract out the storage. Right? And I want to abstract it out in such a way that I'm building a distributed, reliable storage infrastructure. Right? So each of these machines has their own disk, but I want to make it seem like one logical file system across these machines. And if a machine fails or if a disk drive fails, I want to have redundancy across the environment that the framework automatically takes care of for you to kind of sort of keep going forward. So as you look at this distributed environment, the next sort of abstraction you want to look at is some way to do computing across that. So you have these distributed machines that have data on them, and you need to have a way to says, okay, so where is the data? And as we talked about the traditional approach is you move the data to the analytics. One of the things that happens with Hadoop is we want to move the analytics to the data, right? So and that flip in paradigm opens up a whole new opportunity to work and process data. But in order to do that, we need to have a way to be able to distribute the computing to where the data is, right? And so we have to have this distributed computing framework that understands where the data is, which is this concept around data locality, and we need to have a resource manager, right? Because multiple people are going to interact with this environment at the same time. So who's busy, what machine's busy, what machine is not busy, where do I kind of push the workload, right? And so we'll call this our distributed operating system. So initially with Hadoop it started as this batch paradigm, as it had only one way to really interact with Hadoop. But Hadoop sort of evolved so that it can not only do batch, it can do interactive, now it can also do sort of real time. So the data is stored in one kind of common repository, but you have multiple paradigms to interact with that data. And so these are a collection of these data access engines. So as you have this potentially large data lake where you're processing across a cluster, now you need to be able to secure that data, and you want to know who's doing what with that data. So you want to be able to govern it. So you need to have to build some infrastructure to be able to also do that. Right? And you want to have the flexibility to kind of deploy that distributed environment both on-prem, on cloud, and in a hybrid environment. So, and then on top of that, you're sort of building your applications. So as we take this into sort of review, you have this, storage layer, which becomes your data management layer, and you have this notion called Yarn. So Yarn is yet another resource negotiator, which acts as your data operating system, right? And then on top of that, you have these different data access engines, and you have this governance and security infrastructure. And the last concept is really around operations. So yes, you're governing security, but you're really dealing with distributed computing environment. You need an easy way to be able to operate that environment. What's the current state of the environment? What machines are down? What machines are up? What's performing? What's not performing? So we need sort of a framework to also deal with these operations. And then, lastly, you're sort of building out your application. So as we start looking at Apache Hadoop, there's many more other projects, whether it's Apache Pig, Apache Phoenix, Apache Spark, Apache Solar. And one of the things when people start looking into getting started with Apache is they can start getting overwhelmed by the amount of different technologies in the open source you need to deal with, right? Because it seems to be a never-growing, never-stopping list of technologies, whether it's Flume or Hive or Nox or Scoop. So one of the things I want to try to do is not try to cover all 26 projects that you might be leveraging from an Opus perspective, but try to focus on a couple few, right? So the few ones I'm going to focus around is, in particular, we'll cover HDFS. So HDFS is our Hadoop distributed file system, right? That provides that abstraction across those machines. We're going to talk about Yarn, which is our resource negotiator. We're going to talk about a couple of the data access engines. So we'll talk about Pig and Hive. And then we'll also talk some about Spark. And then the other thing we're going to cover is Apache Ambari. Right? So Apache Ambari is the tool and framework that we'll use to sort of operate on our data. So that'll be our focus. So let's talk a little bit about Apache Hadoop, right? So as we look at Apache Hadoop, we're celebrating our 10-year anniversary of Apache Hadoop. Happy birthday, Apache Hadoop, right? So it really sort of started sort of an inspiration from some papers published out of Google. So there's some papers published on the Google file system and Google MapReduce, and the folks down the road at Yahoo said, "Hey, what a great idea! Can we take advantage of that and leverage that for something we're doing here at Yahoo?" And then that kept progressing, and sometime around 2008, folks from Yahoo says, "Hey, this technology is going to just keep adopting faster and grow the technology if we could put it into open source." So Yahoo decided to take what they've been working and leveraging internally and open source it as Apache Hadoop. Right, and so as we look at Apache Hadoop, it has had many different sort of iterations. I'm from Hortonworks. At some point in 2012, we had our first release of a distribution leveraging Apache Hadoop, right? And then Yarn wasn't in the first initial Apache Hadoop. It really came around in Hadoop 2.0, right? And so when we look at Apache Hadoop, right? Apache Hadoop is made up of 4 main components, right? So first and foremost is HDFS, which is our storage layer, right? Second is Yarn, which is our resource negator. Then there's MapReduce, which is a framework to do sort of computation. And this is the original framework that was sort of developed. And then there's Hadoop Core, which is a series of utilities that's used throughout the framework. So this is Apache Hadoop. And how does it actually kind of work? So we're going to focus on HDFS and Yarn some. So each of your compute machines, we're going to call them worker nodes, right? And so you have this large collection of machines similar to what we have in this room. And on those machines, you have a couple of services. One is an HDFS service called the data node, right? So this is where your actual data gets stored. The other service is a node manager that's part of Yarn, right? And what happens with this environment is that HDFS and Yarn, they actually work in 2 components, right? So there's the worker nodes, and there's a series of master or coordinator nodes, right? And so what happens is these master nodes for like HDFS, that's the name node. And the name node knows, hey, if I have data distributed across my cluster, where is that data, right? And if I have multiple copies of that data, where are the different copies, right? And the resource manager, in particular Yarn, says, hey, if I'm doing computation on this, what machines are busy, what machines aren't busy, so kind of how are we going to distribute that work. So with that, we look at building up a cluster. So when you build up a cluster, you're building up a cluster and you have lots of worker nodes, right? So your worker nodes end up being these, right? And you can keep adding worker nodes into your environment, right? So keep growing your capacity. These master services, these coordinating services, you might have just a limited amount of them, right? And depending on your architecture, you're going to set up and allocate resources potentially differently, right? So you have your name node for HDFS and your resource manager with Yarn, and you might have some dedicated hardware that you give to that. So let's get into a little bit more details with HDFS. So HDFS is this scalable file system. It's reliable, and what I mean by reliable is that if a machine goes down with data A, there's other machines in your environment that have that data, and the framework, the Apache Hadoop framework, in particular HDFS, within that knows that a machine went down and can redistribute that data to other nodes, and the work that was happening on those nodes, it can redistribute that work also, right? It's cost effective because you're dealing with commodity hardware, right? So these aren't special storage systems, special compute systems. You're dealing with commodity hardware with local disk, local RAM, and local CPU, right? And you're going to deal with this in a secure manner. So there's all these different file protection environments and some abstractions on top of that to protect that data. So particularly when we look at HDFS, initially with Hadoop, it was really focused around storage on disk, right? So HDFS had an abstraction for mostly storage on disk. But HDFS has continued to evolve, and now we're seeing a sort of abstractions not for we're starting to look at heterogeneous storage environments where you have HDFS data. And then that data is both on disk, it's also on SSD drives, and you can also sort of have these RAM environments so that as you place data within your HDFS environment, and you're looking at hot, cold, and warm data, you can decide to tier how your data gets placed into a different environment. And not only that, we're also looking at storage from a sort of outside the cluster within an S3 or a cloud environment where you want to potentially leverage that. So now HDFS needs to store the data locally, sort of optimize that. And as you're doing computation potentially in the cloud, you also want to be able to leverage that to do sort of computation. And HDFS is evolving to do that. So as we take a closer look at HDFS, we talked about it as a fault-tolerant distributed storage system. And when you load a file data into that file system, what happens is that it gets broken up into chunks and blocks. So you have your logical file that gets broken up into chunks, and those chunks, when they get put onto the file system, you by default have 3 copies, right? And there's an algorithm within HDFS that knows how to distribute that data to that cluster. And if a machine goes down, it knows how to take that block and potentially put it into another node in the cluster. Okay, so that's HDFS. So we talked a little bit about MapReduce, and we talked about this notion about being able to instead of moving data to the computation, move the computation to the data. And the initial framework to do that was MapReduce, right? So again, Apache Hadoop is composed of MapReduce. So there's no such notion as Apache MapReduce. It's just Apache Hadoop MapReduce, Apache Hadoop HDFS, Apache Hadoop Yarn, right? And one of the things that MapReduce did is, hey, I want to be able to push that computation down to where the data is. So let's take an example of how that works, right? So MapReduce takes a large problem and, like many things in engineering, breaks them down into sub-problems. So the map part says, I want to iterate over some large amount of records. I want to extract something of meaning, of interest from each of those records. So as I extract that something of meaning, I then want to kind of organize that in a way where I can process it. So there's a shuffle where I sort through those intermediate results. And then when I want to do a reduce, the reduce notion is about, okay, I've sorted those. I want to now aggregate, summarize, filter, transform these intermediate results. Okay? And then I get some kind of final output. So I start with the data. It's distributed across the cluster. I do a map, right, to iterate over that data. at some point I want to do some aggregation, I do a shuffle to then kind of aggregate it together. So to me, the whole MapReduce notion really comes down to a couple things. One is, when you look at MapReduce, if I wanted to figure out how many nickels and how many dimes people have here in this room, I want to iterate over a large number of records. So I basically now want to iterate over people's pockets, right? And I want to, one way is I can go down each row and says, how many nickels do you have? How many pennies do you have? And I can go down each one, right? Or I can do a map. So on a map, what I want to do is give me a nickel, and I want to assign a value to it. So if you have a nickel, give it a 1. So it's a key value pair. So the key is what you're trying to identify, and the value is, in this case, it's just 1 because I'm counting. So I can distribute this approach across the cluster. So I do a map. So I kind of get all these individual values. Then as what I want to do sort of is catch the intermediate results. I want to shuffle them. So I want to catch them at the end, and it says, okay, now I have nickels and I have pennies. Let me put all my pennies, my collection of penny counts and my collection of nickel counts into different groups. Now I've done my shuffle. Once I've done the shuffle, now I have an opportunity to do the aggregation, right? So I do the aggregation, and I can actually count the number of nickels and the number of pennies I have across this room, right? So I've just taken a problem and broken it down into sort of a distributed computing environment using the framework of MapReduce. Now, MapReduce was the initial framework, and there's many other frameworks that sort of evolved since then. But this notion of mapping and reducing and how that computation happens is an important concept to learn and understand as you're doing computation in the Hadoop environment. Because even if you go into something in Spark, you'll see a map, right? And you'll see an aggregation, right? So this concept keeps getting used, even though it's being used in different permutations. So it's an important concept to kind of learn and understand. So Hadoop 1.0, came out, and it was initially just HDFS, and MapReduce, right? And so it was a very powerful environment. People started building applications on it, but it was sort of like a one-trick pony. If you wanted to have another application, you needed to have another Hadoop cluster, right? So as you can see, as you grow, as you keep growing the amount of applications here, you can keep building more and more clusters. Say, hey, this is not the most cost-effective and the best way to utilize this sort of very special resource, right? It's becoming too siloed. So Hadoop was good, but it had some challenges. One is it was a batch-only architecture, right? And as folks started doing more and more workloads, it says, hey, can we have other ways to interact with that data? In particular, as we have this notion of moving the analytics to the data, hey, I want to be able to do machine learning at a greater scale, and now I might need to kind of hold data in memory and do multiple iterations on it. Can I open up this infrastructure to do other computation on it? So it was single purpose. It was potentially difficult to integrate. And when people talked about non-enterprise grade, enterprise grade, the amount of security governance that was in the initial Hadoop 1 and the ecosystem that was around that time was fairly limited. So that's with Hadoop 2 was the introduction of Yarn, right? And Yarn really opened up Hadoop to be able to support multiple data access engines. So now, yes, you still have the batch MapReduce sort of framework that you deal with, but you also have a wide array of other processing frameworks, right? Some of them are leveraged and built on top of MapReduce, and we'll talk about it. And some of them sort of work directly with that environment. And then there's a way to sort of plug in your additional frameworks. So, and this is a very common, as we think of Yarn as our data operating system, this is a very common pattern in operating systems in general, right? So, if you look at Windows 3.1 or iOS 6, what did they really have in common is they were single purpose operating systems, right? And one of the big their big step forwards was becoming a multitasking operating system, right? And just, now that you become a multitasking operating system, I want to be able to talk on the phone and listen to their music and view a web page and do a Facebook update at the same time, right? So, as we looked at Hadoop, going from Hadoop 1 to Hadoop 2, one of the things is that, in Hadoop 1, all these things were like tightly coupled together. So the API, the engine, and the resource management was all coupled into MapReduce. And as we went to Hadoop 2, these got decoupled into sort of its own environment, right? So the resource management introduced a new component called Yarn, right? And that allowed multiple engines to now be plugged in. So you still have MapReduce, it's still there, but you can also kind of plug in different engines, whether it's Tez or Spark or whatever you want to kind of add into this environment. And so now you have more APIs to work with. And this really brought in this whole notion of improving your utilization. So as we look at sort of an example of utilization, so you can have a Hadoop environment where you're processing data in SQL, and you're doing transformations, and you're doing stream processing all across your cluster, and have this resource management allocate the resource sort of accordingly. So this is sort of the empowerment of Yarn. And one of the things that's happening with Apache Hadoop, so it's our 10-year anniversary of Hadoop, and Hadoop itself keeps evolving, right? So HDFS it keeps evolving in how what it can store and how it can optimize its storage infrastructure. So it has this notion of erasure coding. So instead of being able to have 3 copies of the data, now you can maybe just go and have 1.5 copies. There's some trade-offs when you go in that direction, but if you're looking at petabytes and petabytes of data, you might want to have a more tiered heterogeneous storage sort of infrastructure that you go with. And Yarn itself, Yarn really was about improving your utilization of that distributed computing infrastructure. And there's this sort of notion of Hadoop Next, which really goes and extends Yarn, right? Because as you wanted to plug something into your distributed computing framework with Yarn, you had to deal with a Yarn container. So when you deal with a Yarn container, it was this infrastructure where you plugged in your engine. So if you wanted to plug in additional engines, now you need to kind of make your engine work with that Yarn container. And that has some challenges. And so they try to make it simpler. So there's a project called Slider. So you can slide, right? Make it easier to kind of get these engines into this environment, which was easier, but maybe not easy enough. So one of the notions with Yarn.next is, hey, can we add another container where there's an existing ecosystem to be able to bring more data processing into your distributed computing environment, right? And that's one of the things we're starting to see with Hadoop Next. So one of the things I do want to cover, it's like, wait. So I've been talking for a while now. You're talking about the problems. We talked about Apache Hadoop, Yarn, HDFS, but I'm still confused, right? Because there's Apache Hadoop, and there's these different distributions, but I still see all these different projects. And so one thing I want to sort of point out is, just like Apache Hadoop sort of builds on open source, you have this notion of Apache Hadoop and a Hadoop distribution, right? And that works in a very similar manner, just like Linux. You have a Linux kernel. You can think of it as your Apache Hadoop as the kernel, right? And then you have a distribution, right? And so, how many people here use Linux? Okay, great. How many people have compiled the Linux kernel in the last month? Right? We got one person, right? And it's good. It's good to kind of do that. But once you kind of like, hey, I want to package this whole environment myself, you have to have a sort of a need for doing that. And it brings its own set of sort of challenges. So one of the things that distribution does, it does some packaging, does some integration, right, for that. So hey, I want a way to manage that environment. I want to be able to install and configure and upgrade in a sort of consistent fashion. Leveraging open source technology. So there's Apache Hadoop and the Hadoop distributions. So when you look at a Hadoop distribution, it's made up of this collection of projects based on top of a kernel core, which is Apache Hadoop. Now, when you look at them, many of them have, if you look at the various distributions, there's a lot of things in common, right? So if we sort of look here, right, we'll look at Apache Hadoop, right? And so you look at Hadoop, it's not Apache HDFS, it's not Apache MapReduce, it's not Apache Yarn, it's Apache Hadoop, and those components are part of that. And all these different distributions leverage that sort of kernel infrastructure. And there's a couple of other technologies that many of them do, right? There's this notion called ODPI, which is trying to standardize on a common set of components across a different set of clusters, right? So IBM, Hortonworks, Pivotal have all joined ODPI to kind of have a common infrastructure to make it easier for ISVs to kind of build and innovate around that platform. So there's the common set, but then there's this whole other area where it's not very common, right? And that's where you start seeing a lot of differences across the distributions, right? And these differences really come around not so much around data management and resource management. It's more around security, governance, and operations. And the different distribution vendors package different components, right? Here at Hortonworks, we're focused on completely open, so all the things we package into distribution are other Apache projects completely in the open. So as we look at a distribution, right, and we look at these various pillars, right, these are all the Apache projects that are part of the Hortonworks data platform, right? And one of the things that distribution does is open source keeps evolving independently in independent streams. And so at some point you need to take a snapshot that says, hey, I want to take a snapshot across these different projects, integrate them and leverage that and provide that innovation back to the vendors itself, right? So as we do that, really distributions do two things. One, they provide vertical integration. So they take a data access engine, figure out how to plug it into Yarn, figure out how to leverage HDFS, and provide a particular vertical integration, really focus around performance and scalability, right? The other thing it does horizontal integration. And that horizontal integration is sometimes where you see many differences across the distributions. So how you're doing for that data access engine, how you're doing governance, security, and operations. So as we look at, Hadoop distributions versus Apache Hadoop, a Hadoop distribution defines a stack of components, right? So what's the collection of components that you're actually working with? The other thing is it defines and integrates a series of components both vertically and horizontally, right? It provides some mechanism to provision and upgrade that environment. And it has a series of tools, right? Many times it has UIs or different ways it tries to accelerate, time to value for you. And then they have a different collection of sort of a partner ecosystem. Right, and lastly, at some point you need to get support for this environment. So that's Apache Hadoop, that's Hadoop distributions. And probably fairly quickly I'm going to go through sort of some of the tools. So as you start interacting and people here have the sandbox, did everybody get the sandbox? Does anyone need the sandbox? Okay, great. So as people have that environment and you start interacting with Hadoop, one of the first things that you do is probably bring up Apache Ambari. Right? And so Apache Ambari is your platform to provision, manage, and monitor that Hadoop environment. And Apache Ambari also provides some tooling to do dev and DevOps. So it has a core infrastructure that does provide for this, so the operation install environment, but also has some tools to do DevOps and optimization. So Apache Ambari is very extensible, so you can add to that environment. So how many folks have worked with Eclipse? So Eclipse has this notion where you have the core Eclipse and you have plugins, right, where you can add to that environment. So Apache Ambari, there's a core Apache Ambari that does operations and it has an extensible framework where you can plug in your own extension. And those extensions often referred to as Ambari views, kind of like plugins that you can enrich that Ambari environment. So as we look at Ambari views, one of the first Ambari views that we can work with is the Hive view, right? So it's a way so that you can look at what data sources are available, issue some SQL, right? And look at the results of that SQL, right? And so as you kind of go through the tutorial, you'll be dealing with the Hive view. And those all have a collection of sort of DevOps, right? So if you run a query, right, and you're using Tez, hey, how was that query processed? And they'll have a Tez view. You can break out that job and see how it was run. And if you're doing scheduling with Yarn, you want to build Yarn queues and allocate who can do what work, you can kind of have a view for that also. So you have views where you can look at files, right? you have views where you can deal with SQL. You have views where you can interact with Pig. And as we get started, you'll be actually working through many of these. The other one I kind of want to mention from a sort of interacting perspective is Apache Zeppelin, right? So you have a SQL view, and that SQL view allows you to issue queries, and you can see how those queries are run. But what if you want to sort of build some reporting? What do you want to start doing some other sort of analytics? So Apache Zeppelin is a web-based notebook that allows you to, in a modern way, be able to sort of interact with the data, do potential queries, run Spark, run Pig, right, and build some reports around that environment. Now, you can't necessarily do tuning and troubleshooting, so if you want to do tuning and troubleshooting, you might want to go back to the Ambari views. So lastly, let's talk about data access. So as we talked about data access, so Yarn is this infrastructure that allows multiple paradigms for you to interact with your data. And one of the first ones that people want to do is, how many people here are familiar with Python? How about Scala? How about Java? How about SQL? Right? So SQL is a lingua franca of data access, right? So pretty much anyone and everyone who works with data leverages SQL. So there's a project called Apache Hive that came out of Facebook. It says, hey, this MapReduce framework is fantastic. It's very powerful, but it's a new paradigm I have to learn. I have all these data analysts that already know SQL. Can I give them a SQL access, right? A SQL view to that data, a way to interact with it with SQL. And that's where Apache Hive is. So Apache Hive initially generated MapReduce jobs, but now Apache Hive can generate MapReduce jobs, Tez jobs, and potentially even Spark jobs at some point. And it provides a way for you to plug in sort of other tools. So as you look at Apache Hive, Apache Hive plugs into Yarn. Apache Hive plugs into Yarn, right? And it uses a particular execution engine, right? So in this case, initially it was MapReduce, but it could also now really works with Tez. And then you're dealing with a particular file format. So I worked on DB2 for many years, right? It was a relational database engine. And one of the things about relational database engine that's different from Hadoop is the relational database engine was like a black box, right? So inside of it, there was a file format. Inside of it, there was resource management. Inside of it, there was all this sort of optimization that happened. But it was a black box. You couldn't switch out your storage format. You couldn't switch out your optimization engine. You couldn't switch out different components. And with Apache Hadoop and Hive, you have the ability to plug and play different things, and you could sort of see all the various components. So one of the things is that there's Apache Hive, and there's been this sort of Stinger initiative, so that initially we did start with batch, but we wanted to sort of move to interactive and then to sub-second sort of performance. So during this Hadoop conference, you'll see talks around a technology called LLAP, right? And that technology is really looking at doing improved memory processing to give you sub-second performance with Apache Hive. And this is the amount of SQL that's supported with Hive. It's a growing list. With Hive 2.0, we're starting to see more SQL function coming in and closing the gap on 2011 capability. So the way Hive works is you have your SQL support that's provided, right? There's a Hive server that you interact. There's some metadata that's stored in the H catalog, right? There's different optimization engines that you can leverage, and there's different execution engines. So, Hive was in this abstraction. So instead of writing MapReduce jobs, you wrote Hive, and Hive generated MapReduce. So now with Hive, you have the ability to generate MapReduce, you have Tez, and Spark, right? And you can deal with different storage structures. So I do want to talk a little bit about Tez, right? And so Tez was part of the Stinger initiative to optimize that environment. So we talked about MapReduce, right? So you write when you write a SQL statement, it's not one MapReduce job, but it's a collection of MapReduce. So you do a map and a reduce, then you spill to disk. You do a map and a reduce, then you spill to disk. Then you read from disk, and you do another map and reduce, right? So without going into too much discussion, you could probably identify where the bottleneck is, right? Spilling and reading from disk, right? So Tez optimized that environment and sort of had this notion of a map, reduce, reduce. So that you can do a map and reduce and not having to go back to disk and then keep doing reduce jobs around that environment, which really sped up and started providing interactive SQL capability. So Pig is another framework that was an abstraction on top of MapReduce. Pigland's the language that you actually write in. Why use Pig? So Pig is it's a really, my team work on tutorials, right? And I always keep getting surprised how many people keep looking for Pig tutorials given the amount of different projects out there. And one of the things about Pig is that SQL is the lingua franca, it's fairly easy to use. And Spark is very powerful, but there's a lot of things you might need to learn, whether it's learning Scala, learning Python, learning how to interact with this period language. And Pig can be a very simple language to interact in a distributed environment. So it's like, you haven't done any Pig ever, but it's like, I want to load some data, and I want to pick up, in this case, I want to pick up two files. One is pages, and another one is users. And I want to filter my users by a particular age. Then I want to do a join operation. Then I want to do a group by. And so what I'm actually trying to figure out is what are the top sites that people are going to. So I want to do a group by clicks. Then I want to do order. Then I want to limit that, so I'm going to find the top 5. And then at some point I want to do store, which then persists it back into HDFS. So you never looked at Pig, but without ever looking at Pig, it's a fairly easy sort of language to work with. Again, you have to use the right tool for the right problem. Then you have Apache Spark, which is sort of one of the newer projects, and it gets a lot of attention these days because of its really support for a rich set of developer APIs. So you can work with multiple language, has probably some nice abstractions. But one of the things about Spark that it's initiatives that kind of brought it to life is this ability to do machine learning. So Spark has some libraries to do machine learning in a distributed fashion. It has a rich community, and it plugs into that same sort of Yarn infrastructure. So one of the things I want to point out is there's Apache Spark, and Apache Spark, there's no resource management, right? And there's no storage layer with Spark, right? So when you deal with Spark, most of the time you have to deal with some other data source and potentially deal with some resource negator. So when you look at Apache Spark and Hadoop together, now you're looking at using Yarn as your resource management, and you have HDFS available for storage. And you can look at the different engines that's in Hadoop and connect to them to get access to data. But you can also be able to pull data from outside of Apache Hadoop. Yeah, and so it's like, Spark has this core, right, where you can deal with Scala, Java, Python, R, and a growing list sort of engines. And then it has a series of libraries. So it has a library to deal with machine learning. It has a library to deal with SQL. It's called Spark SQL. It has a library to deal with streaming and GraphX, right? So there's sort of there's Hadoop that provides, Apache Hadoop that provides this abstraction, and then these things are sort of built on top of it. So I'm going to skip a couple slides so we can get to the lab. So the lab is all being done with the sandbox. We'll use the 2.4 sandbox. It provides, it's pre-configured, so it's a single node environment. It's not a distributed environment. You're really going to need a good 8 gigs of RAM. So when you bring up your sandbox, we're going to start with this tutorial called Hello HTTP, right? And you're going to access it by clicking this URL, and then you'll have this this ID and sort of password to kind of go with. Later on, when you do bring up the splash screen, look at these View Advanced options, because you'll see other URLs and IDs and passwords to kind of do further things in the sandbox environment. So our lab today is really focused around doing some data discovery, right? And here's a lab, and I'll write that up on the post, or if you're in front of a browser, if you can go to that website. Okay, so that's the lab we're going to kind of work with. And so there's this fictitious company called the Elephant Wine Company, and they're trying to do this optimization. So they have a bunch of trucks. They have a fleet of trucks out there. They're having some violation, speed, braking, tailgating, and they're basically seeing their insurance come up. They want to be able, they have a lot of existing relational data, but they also have this new streaming data sources coming from their trucks. So they want to be able to uncover some new insight from this new data source in a flexible way. And ideally, they'd be able to do some predictions. So I want to better understand my past and at some point be able to better predict my future. So how are they going to do this? So the way we're going to do this is we're going to be able to quickly store new data. So we don't need to sort of define a schema to be able to ingest some data. So we just take files and start putting them into HDFS. And then as we put these files into HDFS, I want to start exploring that data, and we'll use Hive to do some initial exploration. Then I want to do some calculation of risk. And that calculation of risk, we're going to use either Pig or Spark. Right? And the Pig and Spark do the exact same thing. So you can kind of have a side-by-side comparison of doing something with Pig, doing Spark to do the exact same calculation. And then last point, we're going to generate a report. And we're going to generate a report with Zeppelin. Okay? So as we look at the transformation, we're going to start with some data. We have these two CSVs. We're going to bring them into Hadoop. We're going to create some staging tables. And then we're going to optimize that data by putting them into org. Then we're going to start seeing a series of other transformations using SQL to transform that data to kind of get prepared to do our risk calculation sort of in the middle. So when we do that risk calculation, here's sort of the example that you'll see in Pig. We kind of gone through that. And so at this point we're going to sort of break so we can get started. There's a couple folks here that kind of help out with the sandbox and the tutorials. So Ned, do you mind standing up, or James? Mushtaq, where's Mushtaq? And myself, and I don't know if there's any other SEs. So we'll be around. If you have your sandbox, if you're, is there anyone having issues getting their sandbox up and running? Okay, so we'll start. We'll keep your hands up, James and Ned. So we'll start going through people getting sandbox. You should have at least 8 gigs of RAM. If you don't have 8 gigs of RAM, you have the ability to run the sandbox in Azure, and that's what I would recommend. And I will get started with that. After this, if you want to find additional resources, you can check out developer.hortonworks.com. So today we're here. We'll answer your questions. Going forward, if you have questions, how do you get them answered? There's this thing called Hortonworks Community Connections. Think of a Stack Overflow focused around data and Hadoop, right? And so it's a great way to kind of get answers. So with that, thank you. This is my name, my Twitter. Thanks for coming out. And I guess at this point we'll start doing the lab. If folks have other questions, happy to kind of go around and help folks with the additional questions. So,
put the URL back up?
Oh yeah. Let me put the URL back up. There we go. Okay. Thanks.